They're made of beryllium, which is a really lightweight, stiff metal, instead of glass. That's how we can make them really lightweight. Beryllium's got properties that we like when it gets really cold, because everything changes shape when it gets cold, right? They shrink typically. So remember how I talked about one of the two engineering challenges, one being deployment? The second one is this thing's really cold. We're building it at room temperature in a one gravity environment on the surface of the Earth, right? But it's got to work in a vacuum under weightless conditions, and it's got to work at extremely cold temperatures. So the whole part of the telescope on the shady side of the sunshade, that is going to be around 400 degrees below 0 Fahrenheit, give or take. So the whole cold part of the observatory is going to be really cold. So we've actually had to build it exactly wrong so that it will be exactly right at operating temperature. And that's a real engineering challenge, because everything shrinks when it gets cold, and they shrink at different rates. And some things stop shrinking at certain temperatures, like beryllium basically stops changing shape below 100 Kelvin. So, which is one reason we like it. The hard part is it shrinks a lot from room temperature to 100, but then after you get below 100, it stops changing shape. And that's really important for a mirror, right? Because it's got to have the right shape so that it focuses all the light at the right place. But lots of different materials in this observatory, and they change at different rates. So that whole, building it wrong so it's working exactly right at operating temperature is a big deal.